Okay, you're live. Vipin, if you want to take it away.
Yeah. Hi, everyone. So in our guest speaker series, we have today Moshe, and the talk is all about transforming the edge to a virtual cloud using Hyperledger Fabric. And over to you, Moshe.
So, hi everyone. Thanks for having me here at this for the meeting, and great to be with you. And I'm sharing my my email here, so if somebody is interested in more information or try the approach that I'll be presenting, feel free to reach out to me afterwards. What AnyLog is doing is we are transforming the edge to a virtual cloud. So we know that the edge is a very complicated environment, and I'll talk a little bit about that. What AnyLog does, and I'll try to be very detailed to show you the details of the story. What AnyLog does, it makes the edge an environment which is very simple and easy to interact with. And at a high level, what that means that all the distributed data becomes accessible and available through a single point. So companies or users could interact with their edge data as if it is centralized, although it remains in place, distributed at the edge. And at the same time, the same users can interact with all his edge resources, servers, Raspberry Pis, switches, gateways, and sensors, as if all those distributed resources are a single machine, which makes it very much like a cloud. You log into some web page, and from there you could manage all your data and all your resources. The same thing is achievable using this approach that I'll be showing and explaining. So let's talk first about the problem and the challenges at the edge. So maybe the number one problem is the huge amounts of data. And as people that are familiar with data, we know that even simple problems become very complicated when you have a lot of data. Next to it is a problem that Next to it is an issue where the data is not in one place. The data is distributed all over the place. And we know that there is no efficient technology that allows users to extract insight from data which is distributed. What companies are forced to do in this scenario is to centralize the data. If we continue in this circle, the next thing to mention is that the edge resources are very limited. It's not the same servers and the same setup which you've got at the cloud. You've got different Raspberry Pis, switches, which are not uniform. Connectivity is sometimes lost. So edge resources are lacking or lagging behind what the cloud is able to offer. And then a very common problem, you put some process on some edge nodes, and this process could see local data. But in many cases, to get to the right decision or do the process right, you need to see data which is not locally on your node. So what do you do then? This becomes complicated. Now you have to transfer the data between nodes and write some complex protocols. This is not something which is simple and easy to do. On top of it, one of the motivations to push data to the edge is the real-time, be able to shut a valve quickly when an event happens. And with this setup, with this at the edge where you don't have the resources the way you're used to in the cloud, where data is distributed, that becomes very complicated. And I could go on and on with many, many issues and problems, but maybe one thing which is important to notice, the edge doesn't have the data services that's similar to what the cloud is able to offer. At the edge, you're on your own. Not only you have to build the software, but before that, you have to figure out what you do. In many cases, you have to shoehorn many solutions together. And then even if you build something, now you have to deploy and manage it on many, many nodes. Could be thousands of nodes, which create a very complicated setup. And for those reasons and many others, companies try to minimize their work at the edge and centralize the data And for the things that they've got to resolve at the edge, if you have to shut some valve, you cannot bring the data to the cloud first. You have to figure out how to do it at the edge. And it's in this scenario, it becomes a very complicated process. So that's the state of the edge. And what I'll show you is a way using the blockchain, using Hyperledger Fabric, a way to overcome all those issues. But before I talk on the solution, let me just paint what companies are doing today, how the typical architecture looks like. So you've got edge, edge devices or applications that generate data at the edge. And what companies are doing, first you have to collect the data, have some nodes at the edge that would host the data. And here you have to inject a lot of domain knowledge. You have to understand what data is coming in, what are the sensors, what are the devices that send the data, look at the data, decide this data I need, this data I'll drop, this is too much data, so maybe I'll just take summaries or part of the data. So you build those solutions, and from there, the data goes upstream, and there are more layers, which I'm skipping, but eventually the data would reach out to the cloud, where you host the data in, let's call it domain databases that are built to satisfy the structures and to create the environment where you could connect your applications, and from there you could service the data to the applications. So obviously this is a complicated setup. It takes months to build those things. By the way, over 70% of edge projects fails. And this is just part of the story, right? On top of it, like we said, there are things that you've got to do at the edge, or you need to do at the edge. So now you have to push applications to the edge, which makes the story more complicated. And again, we could go on and talk about this architecture, but there is no other way. That's what companies are building. And obviously, this is project-based. It's hard to build, manage, and scale those setups and those architectures. You end up with multiple software stacks in the different tiers. Data is siloed, and obviously, there is a big impact on the cost. But that's the way companies deal with edge data today. And let me show you kind of a different approach. So the first thing that I would talk about, it's in the context of Hyperledger Fabric. We use it first as a way to deal with the metadata, and I'll talk about a process, and then you'll see how it fits into the bigger picture. So the way that it works, we've got Hyperledger, and we've got nodes that host data, and we'll talk about those nodes. And what happens here is the nodes host the data, Hyperledger hosts the metadata, the information about the data. And this could be, we call the information that we write to the blockchain, we call it policies. And if you were to ask me, so what are those policies? The answer, it could be anything that is important and you care about. So AnyLog as a platform is using some types of policies, but this could be really extended to anything that not only AnyLog cares about, but anything that the other applications that are running at the edge would care about. And you'll see how this comes into play. But some examples of policies, for example, data distribution is a policy where the data is. Information about members, nodes that participate in this game of hosting data, security policies, configurations, all of those things could live in as the metadata, which is hosted on the blockchain, which is different than the data itself. So again, the data lives on those nodes. Those are the blue circles on the left to the blockchain, and the metadata is on the blockchain. And in that context, users, applications, nodes could create policies, and to create a policy or to save a policy or to add a policy to the metadata, all that you need is to create the policy, which is a JSON structure that lists what's the policy is about, and then you give the policy to one of the nodes in the network. It doesn't matter which one. This policy would add the information into the blockchain. So from the application point of view, the process is very simple. It's just a REST request where the policy is being added to a node. The node would take it. It has an API to Hyperledger, would put it on the blockchain. But what's interesting is that if something is added to the blockchain, all the other nodes that participate here have a process which continuously synchronize their metadata, their knowledge with what's being added to the blockchain. And by the way, they could also list the things that they care about, so they don't need to bring everything, but everything that they care about would be available to all those nodes that participate in this process of hosting the data. At the same time, if a node or a user or application needs information which is of the metadata, he could just reach out to any node because all the nodes are in this model are synchronized and ask for whatever he wants, and it would get it back. We will focus in this talk is about data distribution policies. So data distribution policies are when a node posts data, it would register on the blockchain a policy that would say, I'm hosting this type of data. Now, how this comes into play, you'll see in the next slides. But what's important now to remember is that we've got a shared metadata layer, which makes all the metadata available to all the nodes. And if a node or a user adds something to the metadata, this metadata becomes available to all the nodes that participate here. And we'll see how this functionality is being leveraged in managing the data at the edge. So from here, let's just forget it. We'll get back to the blockchain part and how it's being played. Let's switch gears and think about the data for a few minutes, and then we'll see how all those things come together. So in that sense, we've got things that generate data, could be a smart home, got a lot of sensors, lots of things that generate data. What we will do here, we'll take all the data and connect it to a node that hosts AnyLog on it, okay? So data from whatever is generating data here, could be the refrigerator, could be a thermostat, whatever it is, it would go to a node that could sit at the home. This node would get the data, and there is here part of the technology which I will not talk about it in this presentation, but if somebody is interested, again, we'll be happy to share more information offline. But the node gets the data, and what's important to understand is that it knows in an automated way how to manage the data. So you don't need to send an engineer there. All you have to do is take the data from your edge devices, bring it to a node at the edge. This node would look at the data, would know how to host it locally and store it locally. All of that is done with full automation. But then there are other use cases, right? If you think about a car generating a lot of data from a lot of sensors. So again, the same story. We could host the AnyLog node at the trunk of the car. This node would host the data locally. And again, what's important to remember, this is completely automated, no engineers, no domain knowledge. If you remember one of the previous slides, it was all about domain knowledge that needs to be brought to the edge nodes. Here, it's just place AnyLog, connect the devices, and push the data. And then there are so many use cases, right? So with all those use cases, just bring the data to nodes. And by the way, we don't say where those nodes needs to live. It's really up to the user. Could be on the production floor, could be at the local data center, and could be on the device itself, whatever the use case is. And the claim is now, and I'll show you how everything comes together, but the claim is interesting, and it says that there is nothing else that needs to be done. from here on, the data is available to the applications. And what I'll show you, and maybe from the previous slide, you could start to figure it out. But if somebody needs the data, so let's say I'm driving a car and I want to find, and I live near San Francisco, I want to find charging stations available in San Francisco that have a line which is smaller than 5 minutes of wait. I could issue the query and get the result from the edge node rather than from a centralized database. In this model, there is a place for a centralized database. I'll talk about it, but in that context that we're currently talking, you get the data from the edge in real time without intermediaries, very efficient. In the same way, let's say a user or a process wants to deal with energy share, it issues a query, it sees exactly what it would get exactly what it would get if we were to transfer first the data to some centralized database. But here it comes from the edge. And again, everything here is done without engineers. So what's happening here under the hoods is when a query is being issued, we identify the location of the needed of the data at the edge. So we could have millions of nodes in this model. When a query is issued, we identify where the relevant data resides. And I'll show you more details of that. Then it's all a peer-to-peer play. We connect the consumer, the application, with the nodes that host the data. It's all peer-to-peer. It's all done in an automated way. And it's in real time and in a very secure way. So again, I don't have time to talk about the security, but it's a more secure model than the cloud, which is also an interesting topic to discuss. So from here, let me show you how what's going on internally and give you a little bit more details. And then I'll show you a quick demo of how it works, so you get a feel how it looks like. So the first thing is, let's take the nodes and deploy it wherever data is being generated. And again, we don't care where the nodes live, but each one of those nodes is connected to devices, PLCs, sensors, whatever the use case is. Then there is another layer, which we mentioned before, which is, the blockchain layer, which hosts the metadata. And between those nodes and the shared metadata layer, this is this continuous synchronization process where policies are being added, and immediately all those policies are available to all the nodes in the network. So you could think about all those nodes, although they are distributed, they are working against the shared metadata layer, which makes them operate like one unified machine, which is fully synchronized. The next thing to say in that context is that data is being generated from edge devices and being pushed into those nodes at the edge. And like we said before, that's the only thing that needs to be done. From here on, the data is available, and the way that it works, an application needs data, it takes its query and hands the query to one of the nodes in the network. It doesn't matter which one. This node may not have any relevant data, right? But it just brings the query to a node in the network. This node looks at the query at one hand, and it has the shared metadata layer, right? So it knows, and if you remember, we circled the distribution policies, so it understands where the relevant data resides. So it could do a lookup to the blockchain where it says, which are the nodes that host the data of table X, or in the case of machinery, I want to look at machines whose owner are, a particular company, or machines of version Y, or nodes in a region, or whatever. If we go back to the example of the car driving to San Francisco, the car may say, I want to find charging stations in San Francisco. So it would identify the nodes that are relevant. So again, we could have millions of nodes in our network, but here, this query process identified the relevant node that hosts the relevant data. And from here, it becomes a peer-to-peer play, like MapReduce. the query is sent into those nodes at the edge. Each one of those nodes gets processed the query locally. They all return a result to the node that the application is connected to, where all the results are being aggregated and returned as a unified result to the user or application. So that is the basic process. And what's interesting is this process is very generic. The use case doesn't matter. Take it to connected cars, to smart cities, to industrial, to robotics. It's always the same. Issue a query. The query process would identify the nodes that host the relevant data. Those nodes those nodes would process the data locally and return a result to a unified result to the application. So the application sends a query and it sees exactly what it would see if it would work against a centralized database. And I could also argue, I won't go into it, but if somebody's interested, again, we could take it offline or reach out to me. This process is more efficient than running against a centralized database. This is really, we're talking here about real-time or near real-time, and obviously the data remains at the edge. What also is important to say is that the cloud or centralized databases always have a role in the sense that there is some data that has to be in the cloud for other reasons that what we've discussed here, or in addition, or whatever the reason is. So the cloud is like a client to this thing. It's like an application where it could query the data, it could issue a query. This could be a repeatable query, it could be based on events, it could AnyLog has integration into Kafka, for example, and you could put on a rule engine, continuously transfer this data, this piece of data. But the core thing is that you could at least some of the data, and in some cases all of the data, but it really depends on the use case, keep at the edge. And that makes the edge very much like a cloud in the sense that you push data in and then you could query the data out, and everything inside is kind of hidden and fully automated. So you can think about it as extending, the cloud to the edge, or creating a virtual cloud over the edge. And before I show you the demo, here is just a summary slide where on the left side you see all the reasons why the cloud is attractive, why companies are using the cloud, or centralized database in that sense. You manage the data from a single point, right? And that you could do it in the cloud. At the edge, you have those distributed nodes that you did need to deal with each one individually. Well, this approach, from the user point of view, from the application point of view, all the data can be managed and be available from a single point, as if it is centralized, although it remains at the edge. You have a unified view of the data, even if the data remains at the edge using AnyLog. High availability is supported in the cloud, but is missing at the edge. We provide high availability. We won't, again, I don't have time to talk about that here, but this is highly available. It is very secure. And obviously the only reason to push processes to the edge is real time, right? You need the real time. That's the only, not reason, but the only advantage of the edge over the cloud. Well, since you're at the edge with AnyLog, you get also the benefit of interacting with your data in real time. So what I'm trying to say here is, look, here are all the reasons why you move all your data from the edge to the cloud, but we could bring all this functionality to the edge and make the edge appear to you as if it is a centralized database or a cloud. And from here, let me show you a quick demo. So this is a live demo. This is not a mock-up or anything like that. So if you see those circles, those are AnyLog nodes that are deployed all over the world. So if you see a node somewhere, it is really deployed there. And each one of those nodes is connected to PLCs and sensors, depending on the use case. And even now, there is data which is being streamed to all those nodes all over the world. And as we said, that's the only thing that users needs to do: deploy AnyLog, connect your devices, and from here the data is available. And to demonstrate that, we took Grafana and connected it to the network. The network is this collection of nodes. Practically speaking, the network is a little bit vague term. Practically speaking, we take Grafana, connect it to one of the nodes in the network. It's completely decentralized, so it doesn't matter which node. So pick a node. I think I picked this second one from the left, connected Grafana to it. And from here, we could interact with and see all the data as if it lives on the node that we're connected to. And I could move from one data set to another. And this is all real time. So this would move as we speak. Grafana issues the queries as if it is working against a centralized database, but there is no centralized database. The data is distributed all over the world here on those nodes. And users could interact. I could have thousands and thousands of data sets, and there is no problem, no scaling issues. You could just interact with the data as if it lives on the node that you're connected to. And to make it more tangible, let's move to this GUI. This is just a REST GUI. It's like Postman, if you're familiar, or curl. So I can send requests to nodes in the network. And I selected one node. So this is the node that I'm connected to. So it's one node from those nodes, And I'll send, let's maybe send a query to those nodes. So here is an example of a query, and I'm sending the query to the network. I'm not telling the query where it needs to go to, and I'm hitting send, and I'm getting the data back as if I was working against a centralized database. You can see here the data, but there is no centralized database, right? What I've got is just those nodes at the edge. And if I scroll all the way to the bottom, there is a summary section here. And you could see the data came back from 6 nodes. What was happening here is we issued the query to one node, which was the node that you saw at the top. This node looked at the query and looked at the shared metadata and said, I don't have the answer, but I know who does. And it shipped the query to those nodes, to 6 other nodes at the edge that have the data, got the result, aggregated the result, and returned the result into my screen as if it is one physical database, although there is no physical database. It's all distributed all over those edge nodes. So the data came back from 6 nodes, and you could see here the time is listed as 0, and the reason is we don't print fraction of seconds. So it took less than a second to do that. And this is live data which is being ingested right now. And again, everything that I'm showing here is done without a single line of code. It's just deploy AnyLog on edge nodes, configure AnyLog, push your data, and that's it. Now you could run queries. You don't need domain knowledge. You don't need to send engineers. You just need to host AnyLog at your edge. Let me show you, maybe this is a cool example. By the way, those buttons here, you could configure it to frequently used queries and commands that you use. So in the same way, we could monitor the resources. I'll show you a little bit of that. But maybe before, let me show you, here is a different query. But this time, instead of me running the query, I could let you run the query. So if I go here to code, you could run it via curl or this QR code. So if you'll take your cell phone right now and put it against this QR code, you could try it. Here, I did. And you could see the data came back to my cell phone. And if you tried it and you scroll all the way to the bottom, you'll see also that the data came back from multiple nodes at the edge, right? And the idea is that if you tried it, it should work, and unless you have some security block. And the thing to say here is that we didn't send engineers to your cell phone, right? It's very easy to integrate it into your applications. I mean, everything that I do here, you could just place as a REST request to the node. Maybe one more thing that I'll show you on the data side is videos and images. So those are managed in the same way. Keep the videos distributed. Obviously, think about a store with many branches. Could be thousands of cameras. Obviously, you don't want to centralize all of that, and probably you could, even if you want to, you can't. And even if you bring the data to some centralized location, what are you going to do there? So here is an example. So this is a query on the AI part that looks at video, and you could see here the query asks to rank order by the number of people that are visiting the store. So you could see 0, 1 going all the way up to 5 people at some points. But then if I want to see the videos, why centralize it? Let's just bring the videos that I care about. Let's say that I want to see those videos, and then I can just bring just the things that I care about to my application, to where I want to look at it, versus let's take the videos from all the stores all the time and centralize it, which is very inefficient. We all understand the limitations of that. And then the next thing that I'll show you is that and again, I could go with a lot of details, but at high level, the same setup, not only manage the data. The data is obviously the harder thing, the bigger problem, but the same setup manage all the resources. So again, from a single point, in the same way that I interacted with data, I could monitor all my resources. So you could see I could bring to a point, very much like at the cloud, I could sit and through a single point have alerts. So here, I think if this space is under 50%, it flags it as red, or if data is not being ingested, or whatever your use case is, you could monitor all your edge as if it is running through a single point, and as if all your edge is a single machine. So from a single point, you could monitor everything, which makes the edge, the distributed edge, manageable and accessible, very much like the cloud. So since I'm talking to a group with a big interest in the telco, I think there is one more important thing that I want to discuss, which is not technical, but on the business side, which I think is very, very important in the context of telco companies. So if you talk about if you're a telco company, you're obviously looking for a way to leverage the 5G, your private network offering, and so on. And here is the way. I mean, everything that what I showed you here was leveraging the network as the thing that serves the data, which is, I think, very powerful in the context of telco that wants to make their services available. So if we think about the model today, about the role of the telco, we see the edge as a place that generates data, and the telco plays mostly on the purple side, where they serve as pipes to transfer the data from the edge to the cloud. And if you think about what's there, so at the edge, you would find proprietary software. Like we said, there are no standards there. Each company builds its own solution and figures out what to do. And then the networking is the thing that bridges, would create the pipe, would take the data from the edge and bring it to the cloud. So how about moving to a little bit different model? Obviously, those pipes would always need to be there, but there is a place for another model where at the edge part, it's a platform play. So think about AnyLog as something that is being offered as part of the telco infrastructure. And what's interesting here is that if it's provided as part of the networking offering, no changes are required to the telco infrastructure. I mean, you saw the demo; it just works. So it's a kind of an easy add-on for a telco, for a networking proposition. But now the telco is also playing not only as a connector or a pipe between the edge and the cloud, but it also is someone that brings a platform. And when we talk about the edge data or data that remains at the edge, it's the network that connects the data with applications. So the telco, the networking become the thing that serves the data, which is obviously a very interesting role. And the model here is instead of taking data and copying data from the edge to the cloud and make the cloud providers the ones that service the data, this model would always stay. But what about a model next to it where some data remains in place and serviced by the network, by the telco companies to the applications? And you saw the benefits, you saw the value for the users. So what I'm trying to say, there is a really interesting opportunity for the telcos to consider. So be happy to answer any question. And if somebody is interested in trying AnyLog or learning more, feel free to reach out to me. My email is on the screen.
Thanks, Moshe. If participants have question, they can unmute themselves and they can ask. And David, could you check anything on YouTube? Any questions on YouTube?
Yeah, sure. I'll take a look.
Moshe, I have one question about interoperability. Let's suppose the last slide you showed where we are merging edge and network. So let's suppose if we have a different, because in telco, we have a different telco operators play a important role. So how different telco operators network can be merged together to become a virtual data center kind of thing, and then can be shared on the network as well?
Yeah, so the requirements from the network itself is pretty low. There is no restrictions. I mean, it's all based on peer-to-peer. So there are solutions where messages could cross across network offerings, if that's what you're saying. And a company could also deploy, an overlay network. There are a whole lot of ways to approach it. So we don't deal with the network itself. And that's the opportunity, I think, for the telco to say, we could bridge between, every device that you have and a node that would host the data. And then we create this layer where the data is not just, in transition to the cloud, but we could allow you to query your data directly from the edge.
But if network, if data will remain in that network only, then why we need cloud in that case? Means if we are not sharing data with the cloud.
It's really up to you. So there are reasons to move it to the cloud, but it's, you could say, I have a process on an Oracle database that needs the data locally. I mean, it's what we're saying, look, we could make the edge an environment which is similar to the cloud, where you issue a query and get the result. And we could also argue that in many, many cases, it would be more efficient. For sure, it's more cost effective, and we could go on and talk about all the advantages. But there are processes that are not related to what I showed and reasons why a company would want to bring data to the cloud. And, and then in those cases, this setup makes it even easy because, we've got all the integration to the cloud, like I mentioned a connector to Kafka. You could transfer data to the cloud. You don't need to, but you may have business or technical reasons because of something that is not related to what I discussed here that says, this is great, but some data needs to go to the cloud. What we're saying, even if in that case, even if you lower the amount of data that goes to the cloud, you could have big advantages. So let's say you used to move 100%, or let's say 80% of your data you move to the cloud, you could move now 50% or 30%, or in some cases, like you say, you could just rely at the edge. Huge cost saving. Obviously, the data at the edge is serviced in real time, so that's a big advantage. We talked so there is cost, there is real time, there is ownership issues. You could keep everything inside your firewalls. There is a lot of value in what we're doing, but nevertheless, in many cases, you would still need to bring data to the cloud, and it's not contradicting. It just makes it simple to support this requirement if you have such a requirement.
Thanks, Moshe.
Moshe, what is the latency between the query from the edge to one of the distributed centers?
Between the latency between the edge and
when it queries for data, what is the latency?
So you saw in the query example that it was a fraction of a second, right? So it was less than a second. And if we put an overlay network, so this was done without any optimization on the networking side. What we could do is put an overlay network on top of it, and so it would be even more efficient and more predictable and so on. But I tried, but for sure, this is way more efficient than let's take all the. So look, what companies are doing today, because of all the problems that we've discussed at the beginning, they say we don't have much choice, even if it's great to leave data at the edge, there is no solution for it. We've got to bring it to the cloud. So you first have to take all your data from the edge, put it in the cloud, and we understand that it doesn't make sense. I mean, if Google were to say, in order to facilitate search, let's take all the website and move it to some centralized location, we understand it doesn't make sense. But companies are doing it with IoT data, with edge data, because there is no other way. And what I showed you now is that there is another way. You could keep all your data or some of your data at the edge and make it available and accessible without efforts. It's all plug and play. So, you go to a deployment, deploy AnyLog, and then you could do what I've done without engineers, without any effort. This is something that could change the way companies interact with data, and brings an opportunity which wasn't available makes it available. But on the time thing, for sure, this is more efficient than let's take all the data, build those huge databases at the cloud, and then interact with the data. This means that what we're saying, you could keep data at the edge and run queries and get the result very efficiently. And what's transferred on the network is just the query one side and the results back, which is way more efficient than let's move all the data and build those big databases at the cloud.
So are these databases that are distributed, are they just replicas, repositories?
Okay. So I'm not sure what you mean by replicas. So what I showed you is that in this model, you take your data and you push it into nodes at the edge. Each one of those nodes has different data. You've got the data that, if in the industrial floor, so all the machinery that is in this floor would be connected to a node, pushed to this node. And then you could have another industrial plant, which is in a different location. So you'll have a different node there. And you could have a node that is in charging station. Each one of those nodes have different data, right? Okay. But nevertheless, you issue a query, it would go to the nodes that have the relevant data. So that the process knows how to identify where at the edge the relevant data resides and bring it from there. Very much like Google, right? Like you're doing a Google search, it would send you to the websites that are relevant for your search. Here, it's a SQL query. It would send you to the nodes that have the relevant data. There is maybe another question that is kind of implied. on high availability. So nodes have high availability in the sense that you could deploy it such that there are replicas. So obviously the data of a particular node is not replicated on all the nodes, right? But you could say, instead of one node that holds the data, I want to have 2 or 3 nodes that would create replica of each other. So you've got islands of replicas such that if you lose a node, the query would be routed to one of the surviving nodes, and you'll get the high availability this way.
Okay, so it's individual databases at the edge.
Correct.
That you can query from anywhere to that node.
Query from anywhere, but they appear to you as a single unified database. So applications, what they would see when application connects to it, actually I could show you what happens when application connects to so when application connects to the network, what it sees, it's something like that. It sees a list of databases, for example, Lights and Leandro, and for Lights and Leandro, it sees a list of tables, okay? And then for a particular table, it could say, give me the list of columns, right? And then it could issue a query in exactly the same way that it would work against a centralized database. It doesn't care where the data is. But us, as let's say administrators, someone that cares or wants to know, I could look at it from a slightly different view. So again, you see this table this database Lights and Leandro and all its tables, battery, inverter, and so on. And if you go all the way to the right, you could see the physical nodes that host the data. Okay. But the application doesn't care about that. They just issue a query and get the result. The query is funneled to the relevant nodes that host the data.
And the database at the node is dependent on the node capabilities.
Right, that is correct.
Okay.
That is correct. But what's also interesting there is that, this sometimes with a conventional approach, this is the hard decision. When we go back to the project, you need to figure out how much data is there, what compute power I need to set there, where this model is much easier in the sense that it scales horizontally. You could say, okay, I'll start with this node because the data is distributed, right? So if this node is not sufficient, let's add another node and another node, and you just scale by adding nodes, and it doesn't matter that the data is distributed to multiple nodes because the query process, like we've seen, looks at it as a unified collection of data. And actually the distribution helps, because if you add another node, now you added more CPU, and all those nodes that the nodes that participate in the query process work in parallel. So in a way, you are increasing the degree of parallelism and putting less data on each node. So it just helps you in terms of performance and scaling.
Sounds good. Thank you for the explanation, Moshe.
Any more questions? If not, then thanks everyone for joining today. Thanks, Moshe, for accepting our request and such an amazing presentation.
Thank you very much. Really appreciate you being here. Thanks a lot.
Yeah, thanks everyone.
Thank you.
Thank you.
Bye.
Thank you.